Assalamualaikum. My name is Siti Raisha binti Ibrahim. So today our group will be presenting about our mini project. So for the first question, we choose a transfer function that the expression is 10 times the quantity s plus 3 times the quantity s plus 4 divided by quantity s plus 2 times the quantity s plus 3 times the quantity s plus 5. Next, for question 2, to illustrate the amplitude response and phase response of the given transfer function in Scilab using the bird plot technique, the coding shown in the slide calculate the gain crossover frequency, phase crossover frequency, gain margin, and phase margin. The transfer function is defined as 10 times the quantity s plus 3 times the quantity s plus 4 divided by quantity s plus 2 times the quantity s plus 3, the quantity s plus 5. This the coding generates the bird plot using the bird function and then calculate the gain crossover frequency and gain margin using g underscore margin function as well as the phase crossover frequency and phase margin using the p underscore margin function. Finally, the script display the calculated values in the console. This is illustration of amplitude response and phase response simulated in the Scilab. From the simulation of Scilab, we got that gain margin and phase crossover frequency is infinity, while phase margin and gain crossover is 106.99633 and 1.4933287.
For the question 3, the question asks to improve 10% of current phase margin of the response by using lead compensator. To find the value of phase margin improve 10%, we need to use the phase margin current times with 10% and we will get 117.695963 degree. After that, we need to find the phase max. For the phase max, the formula is phase margin required minus phase margin current adding with 15 degree for the lead safety margin. And we get 25.699633 degree. After we get the phase max, we need to find the alpha. And we get for the alpha is 2.53. By using the alpha, we substitute into gain crossover frequency to solve for tau. And we get 0.0676 tau. Finally, after we get all the information, we can calculate the transfer function for the lead compensator. We use Scilab to confirm that phase margin improve 10% satisfy the requirement in question 3 or not. By using the value of transfer function lead compensator, we put it into the Scilab code to get the result. Now, the Scilab result shows that the overall phase margin is 117.43361, which not satisfying the requirement in question 3 for current phase margin improve 10% in lead compensator. Because phase margin required is 117.695963 degree. This is the board plot using Scilab for the lead compensator.
For question 4, use both lead compesator to further improve 10% of the current phase margin of the response. Show the final transfer function of the compesator and its phase and amplitude response. For 10% improvement, we take the current phase margin and times it to 1.10, which is equal to 110%. The calculation equal to 117.6959 plus the safety margin of 5 degree, it is equal to 122.6959. To find the degree, we first need to minus 180 to the 122. It is equal to 57.304. In the Facebook plot, we find the negative 57.304 degree, and then we record the frequency is 0.6425 Hz, which is equal to 4.1736 radian per second. To find the alpha, we first need to find the previous frequency on magnitude board plot, which is 5.858, and then to find the alpha, 5.858 decibel is equal to 20 log alpha, which makes alpha is equal to 1.962. To find tau, we must first make Z is equal to 4.1736 over 10 equal to 0.41736. Then Z is equal to 1 over tau, which makes tau is equal to 2.396. And then rewrite back the equation in GCS form. 1 plus tau s over 1 plus tau alpha s. This is the coding that we have been using. Executing the previous code, we get the output phase margin is 119.70522 degree. The gain crossover frequency is 0.6461230 Hz. And then this is the new transfer function. The phase margin 119.70 is within the safety margin of 122.69. It is satisfy the requirement for. This is the magnitude board plot for the LED network. This is the phase board plot for LED network.
For question 5, which compensator can be used to achieve a 10% improvement of phase margin? 10% improvement phase margin is equal to 117.695963. Comparing the phase margin obtained using the compensators. Lead compensators 117.43361 degrees, which is less than the improved phase margin of 117.695963 degrees. Next, let compensator 122.695963 degrees, which is greater than the improved phase margin of 117.695963 degrees. Based on this calculation, the LED compensator achieved a phase margin greater than desired 10% improvement, while the lead compensator falls short of 10% improvement. Therefore, the lag compensator can be used to achieve 10% improvement in phase margin from the original phase margin.